Hello everybody, my name is Max and I'm a member of the PLATOnics team together with Giovanni, Mariano and Shadi. We are happy to present our approach that is based on learning from demonstration to the Robothon 2023 Gaunt Challenge. Our goal is to facilitate robotic deployment so that humans can be relieved from physical demanding and dull tasks. The human is central to our approach, as we will lay out in this short presentation. Recycling of electronic waste is an important challenge in this context. Deassembling and recycling is needed to keep our environment healthy and livable for future generations. Also, current approaches to recycling are often harmful to the health of individuals, mainly in our global south. In numbers, in 2021, the world population produced 57.4 million metric tons of electronic waste, most of which is not recycled and ends up polluting our environment. While the causes for electronic waste are manifold and not discussed here, solutions to the reduction do not only include recycling, but also repairing, because many times electronic devices are not per se broken, but it is simply not worth repairing them. Cheap robotic solutions could help us extend the life cycles of electronic devices and simplify the recycling process. As both tasks require very fine manipulation skills, we are convinced that robots must be taught by humans to leverage all the implicit knowledge that we, as humans, have learned in our long history. Based on the challenges given by the problem of electronic waste reduction, we can formulate 5 hard requirements. Humans are central to our approach, so the robot must be safe around them. Second, putting robots outside the metal fences introduces a lot of uncertainties caused by humans, localization errors, or robotic controllers. A proposed approach must therefore be robust to these uncertainties. Third, there are simply not enough engineers to program and hardcode all the robots in numbers. So, we want to make the approach accessible to non-expert users. Fourth, fine manipulation requires very accurate motion of the robot. Fifth, as every electronic device is different, a solution must quickly transfer to new devices. Having discussed these requirements, we want to briefly introduce the core features of the PLATOnics solution and convince you that learning from demonstration is the way to go to reduce electronic waste and improve end-of-life treatments. First, we use a Franca Emica Panda arm with a default 2-finger gripper and a simple 3D printed fingertip. Together with the commonly used RealSense D435 and an average Intel NUC i7, our setup is complete. Note the simplicity of our setup, because we believe that the hardware setup must be affordable and simple to obtain to be really competitive in the electronic waste reduction. Humans are central to our approach, so they are explicitly listed as a feature. Specifically, our solution is centered on learning from demonstrations, specifically from non-expert robot programmers. Any human with an understanding of the task can record a trajectory that fulfills the task. I want to pause here for a second to let the approach sink in. Yeah, you're right, you understand it correctly. The human guides the robot to do a task that the human can already perform quite well. By doing so, implicit knowledge that is hard to express in numbers is being passed on to the robot. With that approach, even very cumbersome motions such as opening a hinge door or the wrapping of a cable can be easily programmed, or, as we call it, taught. The controller is very simple, and it's a simple impedance controller to allow us to have a safe motion that can be interfered by the humans at all time. Note that the controller operates in Cartesian space, so that redundancy of the robotic arm can be exploited while executing Cartesian trajectories. To generalize to different positions of the object to interact with, the trajectories must be adapted based on camera feedback. We use a template matching algorithm called SIFT together with active localization. The robot iteratively moves so that the sensed image matches the template for which the skill was taught. Only then, the transformation between teaching and current situation is determined with sufficient accuracy, and the Cartesian trajectories can be transformed and executed. However, pure playback of such trajectory is not enough. We need to use external features of trajectories, such as visuals and haptics. Online, the robot verifies whether images matches the recording and actively corrects for it. It also continuously verifies haptic feedback to sense whether something is going on. In this case, the robot retracts and tries again. Additionally, humans can still adjust trajectories during the first execution to compensate for inaccuracy in the recording. So having laid out all the features, it's very straightforward to imagine the walkthrough. First, you record an RGB template for which you will record the trajectories. Then you record the trajectories and verify their success in having simple playbacks. Then you select an order of the tasks, and then you execute the sequence of the tasks, as you can see below right image, the video. We have implemented a very simple GUI to even simplify these parts. For the bring your own device task, we decided to unmount an old laptop. The process was very simple because our solution is so generalizable and easy to deploy. Here you see some videos of us teaching the robot, for example, the hard drive, the battery, the disk, and we do some probing on the main board. Overall, this whole thing took us about an hour to teach the robot this behavior. So why the PLATOnics? Hopefully you are convinced by now. But to recap briefly, we leverage human demonstrations because programming robots using numbers is tedious and not competitive in the long run. With that philosophy, we can generalize to almost every task that is physically feasible for the robot. Not only is our approach safe in the proximity of humans, it is also cheap and easy to implement. Thanks for having us that participate in the Grand Challenge and for your attention.